All right, IM3 classes. Today we are talking about sine, cosine, and tangent. Right triangle trigonometry. You may remember this from classes last year. If you don't, it's okay. That's why we are reviewing it. So important thing to remember for this is this word SOHCAHTOA. All right, this is going to help you remember the order of the ratios. So the sine, cosine, tangent are each different ratios from a right triangle, and SOHCAHTOA helps you remember what side lengths you're putting in the ratios. So real quick, talk about SOHCAHTOA. So SOH, CAH, and then TOA. I actually like to write it like this: S over S, then O over H, and then C, then A over H, and then T, and then O over A. All right, so what this stands for: the S is sine, the O is opposite, the A is hypotenuse. All right, so the ratio sine is equal to opposite over hypotenuse. All right, so C is cosine, A is adjacent, meaning next to, and then H is hypotenuse again. And I spelled hypotenuse wrong over here. Hypotenuse. So cosine is adjacent over hypotenuse, and then tangent, T is tangent, and then the O is opposite again, and then A is adjacent. So tangent is opposite over adjacent. Let's look how this works on an actual triangle. So again, SOHCAHTOA. Set the ratio. So find the sine of x. So what you're going to do, draw a little eyeball in the x, and we're going to label the side lengths opposite, adjacent, and hypotenuse with respect to x. Right? The hypotenuse is always the longest side. 45 is the hypotenuse is across from the right triangle. The opposite, the eyeball is always looking at the opposite side. So the side opposite the angle is a 36, and then the side next to the angle is the adjacent. All right. So you determine the hypotenuse is going to be the same on every triangle. It's always the longest side. Opposite and adjacent depend on what angle you're looking at. So here we're looking at angle X. So the opposite angle, or the side opposite of the angle, is a 36 adjacent. If we were talking about angle Y, opposite and adjacent would be switched. But anyway, back to here. So sine of X is equal to opposite over hypotenuse. So the opposite is 36, the hypotenuse is 45. So the sine of X is equal to 36 over 45. You can reduce that. That reduces to, divide both by 9, so it'd be 4 over 5. Cosine of X. So cosine is adjacent over hypotenuse. So that's 27 over 45. And that reduces to 3 over 5. And then tangent of X, tangent is opposite over adjacent. So that's going to be 36 over 27, which reduces to 4 over 3. There we go. So that's how you do the angles, opposite over adjacent. Let's look at, practice using a calculator. This is good. So if you're using a scientific calculator, you're going to use a sine, cosine, tangent buttons. You want to make sure your calculator is in degrees. So there's two different settings for a calculator. There's degrees and radians. You need to make sure your calculator is in degrees. There's little buttons on there. When you're in class, I'll help you find it, but there'll be a little button on there that says DEG or RAD. You want to make sure, and then you have the DEG selected. It's in degrees, just to check to make sure you have it selected. The sine of 32 is 0.592. Or 529. The tangent of 41, put that into a calculator. That comes out 2.869. And then cosine of 78 is 0.208 rounded. I actually rounded this one incorrectly. Now I think about it, it's 0.530. So do those. I'm not going to worry about these. You can figure out how to plug in a calculator. Double check to make sure your calculator is in degrees by make sure you get the same answers when you're putting into the calculator. So let's look at an example here. Oh, a little flow chart. The SOHCAHTOA I think is helpful, but for a lot of trigonometry, I have a lot of flow charts for these things. We can go back and talk about this in class, but we're going to skip to a problem. So we're going to find x. All right. So the problem is find the side length. We know what the hypotenuse is, and we're given this one angle here. All right. So I'm going to label the side lengths opposite, adjacent, hypotenuse, base in relation to this angle. So the longest side is always the hypotenuse. And then the side, so opposite, the eyeball here is looking at the opposite sides. The x is the opposite. This one, we don't really need it, but this would be the adjacent side. So now that we know what the sides are, opposite, adjacent, hypotenuse in relation to this angle, we can set up a trig function. So remember, SOHCAHTOA. So I know the hypotenuse and I'm looking for the opposite. So the sine uses the opposite and hypotenuse. So I'm going to use a sine function on this. So to set this up, I'm going to take the sine of the angle is equal to, say, equal to the ratio. So the ratio opposite over hypotenuse, that's going to be x over 10. All right. Solve for x. So from here, I'm going to multiply both sides by 10. So these 10s cancel out and just put that on a calculator. So it's going to be the sine of 50 times 10 is 7.66. So after you do put that in the calculator, is 7.66 is equal to x. There we go. Let's do another example. So again, label the side length. So we're using this 20-degree angle. Side across from here is the adjacent, or no, it's not. It's the opposite. The eyeball's looking at the opposite. The 15 is the longest side, so that's going to be the hypotenuse. This is the adjacent side next to it. So remember, SOHCAHTOA. I know the hypotenuse. So if you look, we know the hypotenuse. We are looking for the adjacent. So it's the cosine that uses the adjacent and the hypotenuse. So I'm going to do cosine. I don't need to write the actual word. Cosine of 20 is equal to the adjacent over the hypotenuse, which is 15. And then real easy to solve, just multiply both sides by 15. I'll cancel out. So cosine of 20 times 15 comes out to 14.09. Actually, that's 0.95. That rounds to 14.10 rounded. All right. Another example. So you're going to label the side lengths here. Actually, I'm going to label the hypotenuse first, the angle or the side across from the right angle. The eyeball is always looking at the opposite. And then we have the adjacent. So remember, SOHCAHTOA ka, toa. So we are looking for the opposite side, and we know the adjacent side. So the trig function that uses the O and the A is the tangent. So we're going to do the tangent of 15 is equal to the opposite over the adjacent. So solve, just multiply both sides by 12. That cancels out. 12 times tangent of 15. Do the 15 tangent times 12 equals 3.22 rounded. So x is 3.22. All right, so another example. This is actually lesson used to be split up into 2 days. That's why I have these here. But anyway, still we're going to look at the side length. So label the sides. The longest side crossing right angle here. This is the hypotenuse. The eyeball is always looking at the opposite side, so it leaves this to be the adjacent side. So always don't forget so toa. I know, so I'm looking for the hypotenuse, and I know the opposite. So I need the trig function that uses opposite and hypotenuse. This is supposed to be an H. Opposite and hypotenuse is the sine. So I'm going to do sine of 31 degrees is equal to the opposite, which is 5 over the hypotenuse. All right. So here, there's a couple different steps you can. I'll show you all the algebra behind it first. I'm going to multiply both sides by x. So I'll get the x's to cancel out. So I get x times the sine of 31 is equal to 5. Yeah, 5. And then divide both sides by the sine of 31. So this cancels out, and you get x is equal to 5 times the sine of 31. That looks like a lot of algebra, but you don't have to do that every single time, because when that unknown side length is on the bottom, so I'm just going to rewrite this real quick. So I have the sine of 31 is equal to 5 over x. Notice that after it's all said and done, the only thing that happened is the sine of 31 and the x just switch spots, right? Sine of 31, x just switch spots. So that's the quick way to solving these. Just switch those spots, you're done. You can do the whole algebra each time or just switch the spots. Save some time. But anyway, on the calculator, 5 divided by sine of 31 is equal to 9.71. All right. One more example. All right. So eyeball looking over here. So that means this is the opposite. This longest side here is the hypotenuse. This is the adjacent side. All right. So paying attention to what we're looking for. So we know the opposite. We are looking for the adjacent side. So ka, toa. The opposite and adjacent, O and A. So the trig function that uses O and A is toa. So I'm going to do the tangent of 17 is equal to the opposite, which is 22, over the adjacent x. I'm just going to do that little shortcut to solve for x. I'm going to take this, switch these two, switch it with the x. So x is equal to the 22 divided by tangent of 17. I'm going to put that in a calculator. here. So 22 divided by the tangent of 17 equals 71.9. Let me double check that. This is a little big. 22 divided by 17 tangent. No, all right, 71.96 rounded. And there we go. That will do it for today. The next lesson, what we're going to do is, given side lengths, we're going to find missing angle measures using SOHCAHTOA. So we'll see you next time.